Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. So let us start today's class. Today's class our subject is theory of machines, right? Today's class our subject is theory of machines. In theory of machines, in previous classes already we have discussed basics related to the theory of machines, that is kinematics of machines. And today's class, in this subject we are going to discuss the topics mechanisms with lower pace, acceleration in mechanisms, velocity in mechanisms. These topics we will see few important points which will be helpful for your assistant engineering examination preparation. Okay, right friends? So now we will start. Let us start today's class. Right. The total number of instantaneous centers for a mechanism consisting of n links are n into n minus 1 by 2. According to Aronhold-Kennedy's theorem, if three bodies move relatively to each other, their instantaneous centers will lie on a straight line. In a mechanism, the fixed instantaneous centers are those centers which remain in the same place for all configurations of the mechanism. The instantaneous centers which vary with the configuration of the mechanism are called neither fixed nor permanent instantaneous centers. When a slider moves on a fixed link having curved surface, their instantaneous center lies at the center of curvature. The direction of linear velocity of any point on a link with respect to another point on the same link is perpendicular to the link joining the points. The magnitude of linear velocity of a point B on a link AB relative to point A is omega into AB, where omega is angular velocity of the link AB. Right friends? So it's always better once you are reading any topic, once you are understanding any topic, you write some short notes what you understand from that topic in your own style, so that will be helpful for your revision time. All right, now we will continue. The two links OA and OB are connected by a pin joint at O. If the link OA turns with angular velocity omega rad per seconds in the clockwise direction and the link OB turns with angular velocity omega 2 rad per second in the anti-clockwise direction, then the rubbing velocity at the pin joint O is omega 1 plus omega 2 into R. Okay, so the rubbing velocity at the pin joint O is omega 1 plus omega 2 into R, where R is the radius of the pin at O, right? If both the links OA and OB turn in clockwise direction, then the rubbing velocity at the pin joint O is omega 1 minus omega 2 into R. So here you have to understand the question properly. Okay, so in this case the statement is saying that if OA and OB turn in clockwise direction, then the rubbing velocity at the pin joint O is omega 1 minus omega 2 into R. Whereas previous case it is you can see in the previous case two links OA and OB are connected by a pin joint at O. If the link OA turns with angular velocity omega rad per seconds in the clockwise direction. So previous case the condition here it is clockwise direction. If it is clockwise direction, what we are getting the resultant omega 1 plus omega 2 into R, and whether it is clockwise direction, right, turn into clockwise direction, right, then here the rubbing velocity omega 1 minus omega 2 into r. Okay, so you have to read it properly, then only you can understand what the examiner is asking exactly. Okay, right. Next, here in a 4-bar mechanism as shown in this figure, this is a 4-bar mechanism A, B, C, D. Okay, in a 4-bar mechanism as shown in figure, if a force Fa is acting at a point A, so this is point A. At this point A, force Fa is acting at point A in the direction of its velocity Va. So at this point A, the direction of velocity is Va, and a force Fb is transmitted to the joint B. So force Fb is transmitted to the joint B in the direction of its velocity Vb, then the ideal mechanical advantage is equal to Fb by Fa. Okay, so like that you have to see the diagram properly, how the connectivity is provided in this diagram. See the connectivity as per mentioned in the statement. So based on the connectivity, plot the points properly, understand the transmission of the force, and select the proper option which is related to the diagram. Okay, now right. Next we'll move the component of the acceleration parallel to the velocity of the particle at the given instant is called tangential component. A point B on a rigid link AB moves with respect to A with angular velocity omega rad per second. The radial component of the acceleration of B with respect to A is B square BA by AB, where VBA is linear velocity of B with respect to A, that is equal to omega into AB, right? A point B on a rigid link AB moves with respect A with angular velocity omega rad per second. The angular acceleration of the link AB is a to the power t BA divided by AB. Okay. Next, a point B on a rigid link AB moves with respect to A with angular velocity omega rad per second. The total acceleration of B with respect to A will be equal to vector sum of radial component and tangential component. Next, here see the Coriolis component of acceleration is taken into account for quick return motion mechanism. Okay, so these type of questions we can expect in our exam. Okay, so these are from the fundamentals of kinematics of machinery. So based on this Coriolis component, pantograph, these type of questions we can expect in our exam. Next, listen, in a pantograph all the pairs are turning pairs. Okay, in a pantograph all the pairs are turning pairs. Next, Peculiar's mechanism and Hart's mechanism is made up of turning pairs. Okay, Peculiar's mechanism and Hart's mechanism is made up of turning pairs. Next, pantograph mechanism is used to enlarge or reduce the size of a drawing. Okay, pantograph. You may get a question, which type of mechanism is used for enlarging or reducing the size of a drawing. So for such particular question, you can select the exact option is pantograph. Okay, right. Now we'll proceed. The Ackermann steering gear mechanism is preferred to the Davis steering gear mechanism because whole of the mechanism in the Ackermann steering gear is on the back of the front wheels. Okay, this is one of the advantage we can say. And the Ackermann steering gear consists of turning pairs. Okay, so you might get a question here. Ackermann steering consists of which pairs? Okay, so you can, in that case you can select turning pairs, right? Next, the driving and listen here, the driving and driven shafts connected by a Hooke's joint will have equal speeds if tan theta is equal to plus or minus root cos alpha, where theta is angle through which the driving shaft turns and alpha is angle of inclination of the driving and driven shafts. Okay friends, so that's all for today's class, right? So if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Please discuss with your friends the class work going on in our channel. I think this material will be definitely helpful for your assistant engineering exam conducted by Andhra Pradesh Public Service Commission. Okay, so thank you very much. Thank you for watching.